So we'll record this one. All right, so if we're working with this one here, you have an ROX, vertical compression of 1/2, we're moving it left 3 and up 7. Left 3, up 7. Parent function is a parabola, which would open up that, but we're going to reflect it. So it flips down. Then we're going to compress it. Half the distance. So this. Domain of a parabola would be all reals. Your range would do from negative infinity. Remember, it needs to be on the left side, all the way to positive 7. Remember, that was one of the biggest mistakes I saw made on the range, is that you had the negative infinity on the wrong side. You cannot go 7 to negative infinity. That is wrong. Do not do that. Vertex, negative 3, 7. X equals negative 3. X plus 3 times X plus 3 plus 7. Now I'm going through this pretty quickly because I've given you time already to go ahead and work on this. So, but when you multiply these together, it's going to give you x squared plus 6x plus 9. Multiply a negative 1/2 to each of those. That would be y equals negative 1/2 x squared minus 3x. Distributing 1/2 to each of those. The last one would be a negative 9 over 2 plus 7 over 1. That's going to give me a negative 1/2 x squared, a minus 3x, and I just need to put these together. So Kevin, what is my common denominator? 2. So I'm going to put a 2 right there and a 2 right there, and that will make that 14. Which will end up giving me a negative, positive 5/2. Which makes sense because here, look at this. 1, 2, 2.5. Right there it is. My y-intercept is 0, 5/2. A corresponding point to that 5/2, but it's just on this side over here. And so if that distance is 3, then that distance is 3. So I'm at negative 6. We need to be really, really good, even if these are fractions, you need to be really good at writing them in standard form. Okay? It should become like second nature to you. Especially dealing with these easy, I say these are easy fractions to kind of work with. All right? And so this week's theme, hopefully, in our openers is all fractions because I did work on this yesterday afternoon. So I wanted to make sure that you guys had different openers than what we've already done. Okay? Continue the progress. Questions? Again, this is practice for when we're right at the beginning so we can get this kind of out of our way, move it along. And I guess we can take a look at our homework. Does anybody have any questions on 311? It's 311. It's a homework packet. Swafford, I don't know if you got a copy of this homework packet. It's a big stack in the middle right there in the front. No, it's the one on the left side. Sorry. It'll say problem set 10 on it. No, on the table. Right there. Yes. Number 9. Let's take a look at number 9. Woo! Look at that one. That one looks fun. Yes. I think this one's fun. I remember creating this one. All right, now. It's a lot of fun. So if I'm looking at this problem, I have 1, 2 terms, correct? 2 terms, and what do I have right there in the middle? Minus sign, which means this is probably and could be a difference of perfect squares. It could be. Or it could be a sums and difference of cubes. I do have 343 sitting right there, right? Which is a what? What is 343? Perfect square, perfect cube? That's a perfect cube. And what is 343 if it's perfect cubes? What are they? How'd you get it? What number? 7 is right. That's 7 times 7 times 7, correct? What do you notice about that? There's a 7. There's 3 7s there. So that's like 7 to the 3rd power, which means I can pull out what? A 7. Not 6 of them, but we can pull out 1. Okay? So that would leave me 49. Does that make sense? Because that's 7 squared. Now it's looking more like what? The difference of perfect squares. All right. So, but most of us would already had done what? What do we normally start with anyway? Yeah, our GCF or our fractions. We got negative exponents. We work with our fractions first. So I would have rewrote this as 343 x to the 4th all over y cubed minus 7y all over x squared. This is the way I would have started this problem. Now, I pointed out the fact that there is 2 terms of minus sign, so you can understand that we're trying to make this a difference of perfect squares when we get done. Okay, so this is where we're going to end up. So that way, if you got that kind of pre-knowledge that this is a difference of perfect squares, maybe that might help you figure this out. So I need my denominators to match. So, Colton, what does this side need at that side? I need to make my denominators the same. So this needs a what? Yeah, it needs an x squared. And this one needs a y cubed. All right. So now these denominators right here match. So we're going to yank them out. So in this case here, I'm going to get 1 over x squared y cubed, leaving me 343 x to the 6th minus 7y to the 4th powers. Now over here in blue, I had already mapped out that I'm actually going to pull the 7 off the top of this. I'm going to pull a 7 out of these. So this will end up being 7 over x squared y cubed, leaving me 49 x to the 6th minus y to the 4th. You see how that happened? Now, Kylie, you notice this is what? Perfect squares. So I'm going to put the 7x squared y cubed out front, and then I'm going to create my 2 parentheses, 7x to the 3rd and 7x to the 3rd, and y to the 2nd, y to the 2nd, and a plus and a minus. Thank you. Way to finish it. Good job. All right, so that's what that will look like. Okay? It looks crazy. It looked like it might be a cubic, right? That was by design. I was trying to get you. All right? I was trying to get you to do a cubic pattern on that and not a square pattern. But you guys are too brilliant for that, so good. All right. Next question. Any others? I can see how Dancing with the Stars probably got in the way. Well, I know why you were doing Dancing with the Stars. So, oh, Sylvie's good. She's good. You need a. That's perfect. She's not me. Pre-calculus. In Unified 11. Should get on you. Yeah, find something to work on. Correct. All right. No other questions? All right. Now we're going to go to notes. We're going to finish up our notes. So find your notes. I think we're starting with, that was the review worksheet. We stopped at number 9. We're going to do number 10. Right? We did 9 yesterday. We're doing 10 now. All right, so what's wrong with number 10? There's a fraction, so we got to get rid of that fraction by creating more fractions. All the same, which they need to be a 2. So 1/2 comes out and makes it 6p squared minus p minus 40. All right, now, this when we get to this problem, this one's got a very, very unique technique in it. It's going to help you narrow down and speed up your process, all right, on a lot of factoring with trial and error. Okay, so this one's is like a superstar problem. Okay, now, do you see there's a 6 there, a 1 there, and a 40 there? Is there a GCF in 6, 1, and 40? Colton says no. There's 1, but that doesn't count. All right. So in this case here, there is no GCF. Okay. So we do not have a greatest common factor other than 1. So there's no GCF. Now, take a look at these numbers we're going to use. We're going to take our 40 and we're going to break it down. So what's our factors of 40? And then over here, I have what? All right, so I'm going to go against the grain a little bit here today. Instead of using 5 and 8, I'm going to start with 2 and 20. Okay? I normally start at the very bottom, but this is going to try to help you explain what's going on here. So here is 2 and here is 20. And 1 has to be what? What's your signs on this one? How do I get a negative 40? Positive and a negative. Doesn't matter which one, just pick one. All right, so the 1/2 still out front. Now, I'm looking at the front number. We got the 1 and 6, 2 and 3. Let's go ahead and pick 2 and 3. It's the letter P, not X. Sorry. There's something wrong with this problem. Right now, I could stop here and say, this doesn't work. What do you notice about those two numbers? Ellie, what do you notice about 2p and 2? Yeah, they're both even and they're both positive, so we can do what? Could we not pull a 2 out? Then that means, Cheyenne, that there's a 2 in all of these up here, if that can happen. That means there should be a GCF. If there's a GCF in your factor, then there would be a GCF in the original problem. But we know that there's not a GCF. I cannot put 2 with the 2. All right? So that's a big nope. I can't do that. And I cannot put the 2 with the 20. So if I change this around right now and I put the 2 right here and the 3 right here, Well, then that would create a GCF of 2 in those two. Does it make sense? Which we know we do not have a GCF, okay, of 2 in the original problem. So therefore, we cannot put 2 and 3 with 2 and 20, right? So 2 and 20 absolutely 100% cannot happen. Is there another set of numbers over here that cannot work? So I can't put the 1 and 6 in with the 2 and 20 either, because if I do 1, 6, right, and then I do 2 and 20, then I have, again, an even situation. I have a GCF. I can't do that. So if I put 2 and 3, I cannot put 4 and 10 here either, because 2 and 10 are even, correct? So it doesn't work. I could put, would I put 10 here and 4 here? Again, I get even and even, so it doesn't work. So right off the bat, because I have 2 and 3, I have an even number, and these are even evens over here, I can't use those. I would have to use 5 and 8 or 1 and 40. Okay? So guaranteed here, I'm going to put 5 down in 8, but can I put them right there in that spot? Because what happened? I put the 8 with the 2. No, I can't do that. The 8 absolutely 100 positive has to go with the 3 and be with the 3 there. And the 5 has to go here.
You could put like the 40 with the 3 and the 1 with the 2.
Yeah, so if I did 2 and 3, I could put the 40 with the 3 and the 1 with the 2. Correct. That could have been a possibility. You're right, okay? But since this, it kind of makes sense, you can't have a GCF within your factors if there is no GCF in the original problem. Let's do the math on that real quick. What is 8 times 2? 16. What's this one? And what do you get when you put 16 and minus 15 together? I get a positive 1p. So I've got the right number, wrong sign. So all I have to do is switch the signs. Here it is. Okay, so using that technique can help you if you've got a lot of like even numbers. Okay, it can eliminate a lot. Like if I was doing like 6p squared minus 5p, I'll use that because I'm going to create one up here. I'm going to make one up real quick. Minus 24. Your factors of 24 are 1 times 24, like 2 times 12, and 3 times 8, and 4 times 6. My factors of 6 are what? 1 times 6 and 2 times 3. So when I'm creating this over here, I've got, if I put 4 and 6 down, I got a plus and a minus. If I put 2x here and 3 here, this is automatically a fail. It will not work. Because, again, I have a GCF of 2 in those 2 spots. Okay? So it won't work. I can't even switch them. Right? I can't switch the locations. If I put a 2 here and a 3 here, again, it will not work because those are both even. So therefore, 4 and 6 cannot be a possibility. So then I would have to try what? 3 and 8. When I try 3 and 8, I put 3 here and 8 here. If I'm using 2 and 3, I cannot put the 2 with the 8, and I cannot put the 3 with the 3, because then that would make a GCF of 3 in that one and a GCF of 2 in that one, and we don't have any GCF in this problem. So therefore, I would have to put the 3 with the 8 and the 2 with the 3 in order to make that even possible. Okay? So if you're doing your trial and error and you need to be sus about if you get a GCF in your factors. Okay? Now, so I said that today, and then I had somebody work on their homework, and they got one, and they came down here, and they got an even and an even, and it was what worked. There was like a 6 and a, there was like a 2 and a 4, and she goes, but it can't work because you told me it has a GCF. I said, yes, you can't have a GCF if there's not a GCF up here. But the problem had a 4 right here, and they were all even, so you could have pulled out a 2. Okay? So you need to be sus of it. Doesn't mean that it doesn't work. Okay? You need to make sure that it wasn't a GCF in the original problem. All right? So always go back first, make sure there's no GCF before you kind of go like, hey, it doesn't work. Okay? Check to see if they're all even. So this can help you narrow down your search so you don't have to look at so many. Now, if you want to go through all of them, go ahead. You can do them all. All right? But it's really quick and easy to narrow them down. So let's take a look at number 13 real quick, since it's very similar to number 10 in that format. It looks weird right here, doesn't it? I've got a 2/3 and 1/3. How do you know if you have trial and error? Well, trial and error, remember, I told you it has 3 terms. 1, 2, 3. If this is a squared, then the middle term has to have an a in it. If this is b squared, then it would have to have a b here. These powers here have to be half, so we're looking for a half. So a student was asking me today, Jesslyn was asking me this morning, if I had a to the third here and an a here and a b squared here and a b here, is that trial and error? And the answer is no, it can't be trial and error. The outside numbers have to be even, all right? So the powers here have to be even, and these have to be half of whatever the even numbers are. So if this was a to the 6th power, then that would be a third, then that would be a trial and error question. So that's how you determine if you have trial and error. And congratulations to the volleyball team. They made their regional ones champs. So they clean sweep Science Hill easily. Just beat them. So congrats. I watched the game yesterday, or the end of the game. Got off. Was practicing, and when I got off deck, I walked over and they were playing the game. Yeah, I used to. No, I don't get in the water. All right, now I'm allergic to it. I found out later. I was like Kate found she was gluten. She's gluten free, so that's the same. I was allergic to water. If I get in the water, I'll drown. So, right, same way as if she eats gluten, she'll die. Well, I found out I'm allergic to it. It's a total joke, Colton. All right, now, this is 1 times 4 and 2 times 2. This is 1 times 6 and 2 times 3. Set your parentheses up. I have a plus and a plus. Guess what number I cannot use? Oh, yeah. You got to walk a long way. It's the little theater's way over there to get your picture made. Yeah.
Oh, I forgot about that.
You're good.
Katie, where's this picture that can I catch us in the
little theater? All right, so let's start with 2 and 3 over here. If I put 2x to the 1/3 right here and 3x to the 1/3 right here, after knowing what I just said, what numbers out of these can I not put in? 2 and 2 will not work. So Swafford, if I put 2 right here and 2 right here, it will not work because that has a GCF of 2. 6, 11, and 4 do not have GCFs, right? So no GCF, then therefore it cannot work. So 2 and 2 is out, so you have to remove that. Because if I used 1 and 6, 6 can't go with 2 either, so it won't work. So all I got is 1 and 4. So if I use 1 and 4 and 2 and 3, what cannot put, what can I not put with the 2? The 4. So I have to put the 1 and the 4 there. That's the only location I have. Now, if we do our math here, what is 8 times 4? I'm sorry, 2 times 4 is 8, and then this would be 3. 8 and 3 gives you 11. So I didn't even have to think about it. There was no trial and error in that because I'm kind of forced to use those numbers. Okay? All right, looking at number 14. We'll do that one real quick. What do you notice about the 4? It's larger than what? Our normal 2. Anytime you have something that is larger than 2, it's a possibility that it will refactor. All right, so let's go through and do this real quick. You only got 1 and 3, and you have 1 and 2. So I'm going to put 1 and 3 down. I'm going to put a minus and a plus down. I'm going to put a x squared and 2x squared in place. I'm going to check my work. 3 and minus 2 would give me 1, and so it works. But what do you know, Cheyenne? So when I see a higher power, look at your answer. So I'm going to look real close at this and this. Cheyenne goes, oh, wait. I know. There's 2 terms and there's perfect squares and a minus sign, so I can factor that. See it now? You see it before? Good. I knew you were really good at factoring, but just double check. There it is. All right. Knowing that, let's go down here to number 17. Again, if I'm looking at 17, what do you notice about the 6? There's no 7 that goes with it. Oh, there is a 7. There's a 7 and 17, so 17 and 6. So what? August? Is that what you said?
Yeah.
I'm so glad. All right. So I'm looking at these factors right here. Now, if I don't pay attention, I write down 1 times 9 and 3 times 3, and I write down 1 times 3 right here, and I do my sets of parentheses, and I go a plus, and I put 3 here and 3 here, and I go, this is what happened earlier today. They said, well, I can't put the 3 here. I'm not allowed. Because then that would give me a GCF right here, correct? But Abigail, what do you notice about that right there? What's 3, 12, and 9 have in common? Yeah, so there was a GCF in this problem. So that can happen because I didn't pull the 3 out first. Does that make sense? So this happens within your homework. If you're not paying attention to your homework and looking for GCFs, and you just start doing trial and error without looking for your GCFs, this scenario can happen. Okay? So I've got to pull the 3 out. Thank you. So you've got to yank that 3 out of this to make that 3 and then x cubed plus 1. I would have done this problem. I noticed there was a 3 right off the bat. I would have rewrote this problem as x to the 6 plus 4x cubed plus 3. And then when I factored this, I would have had x cubed plus 1 plus 3. This is where I would have been. But if you have to, you can have that happen. Okay? Now, again, look at your answers. That's an x to the 6. It's higher than a 2. You've got to look at your factors in your answers. And what do you notice?
You look like my uncle's a dentist.
Is it Sephora Tooth Hurty? So yeah, you're pointing was at Tooth Hurty. You're going to the dentist. Tooth Hurty. Yeah, Tooth Hurty. All right.
You're such a smart guy.
I tried.
You look like you'd be a dentist.
Low key would never do that. All right, now. High key would never either. So, guys, my point of this one is take a look at this x cubed plus 1 and this x cubed plus 1. Those are perfect cubes and a plus sign. So you will have an x and an x and an x and a 1 and a 1 and a 1. And you're going to have to do the small parentheses and a large parentheses thing. The x cubed plus 3, 3 is not a perfect cube. Okay? So x and a 1. X squared, x and 1 here. If you don't remember the pattern, remember you're taking these here and you're multiplying them to get to each of these terms right here. Yes. And don't forget your symbols. Same, opposite, always positive. So this would be your final answer. Here you go. Refresh. Do the little circle thing at the top and let it kind of refresh. Because that says like offline or whatever, so it kind of freaks out. Make sure it's inside out. You get this.
Oh, it's not.
The seam's on the outside.
It's the shirt. What kind of like Velcro badges?
Well, I had an uncle who used to wear his socks inside out because he didn't like the seam on his toes, so he would turn them inside out. It seemed kind of weird to me. Like it was uncomfortable for his seam to be towards his toes.
Look, the tag's on this side.
Yeah, it's inside out.
The tag is on the inside.
Oh, okay.
See, look.
Yeah, they made that weird too.
It's three people.
All right. So, lesson learned. Hopefully, in this case here, you are now looking for, if you have a higher power, when you are doing your trial and error, that you will look, and it doesn't matter which problem is, if you have higher powers, higher than 2, then you need to make sure you're looking for more factoring. All right, let's take a look at number 16. That one will be pretty easy. Factors of 30 are 2n, 3, 5, 6. So when I'm doing this, what you think? What number did you think? Five and 6. It gives me 1 if I subtract them, right? So plus 6 minus 5. Bam. I don't even know why I have that problem there. All right, now take a look at number 15. What do you know about that one? Ah, good job. Good eye. So there is a 2 involved. So yank that out first. And then that makes it really, really simple. Because then I have an x to the n and x to the n. One's positive and one's negative, and I have 1 and 3. My only options are 1 and 3. I have a positive 2, so I need the 3 to be larger than the 1 in order for this to work. You do it exactly the same, just has the letter N in it. But that would be your final answer. Questions? All right, you ready for those that have the parentheses in it? Because those are the ones that most students have problems with. All right. Huh? We did 15, 16, and 17 already. Yeah. So I'm looking at number 11 and number 12. All right, now, so if this A and B is bothering you, and it again, remember, you want to think of it as an object, like a platter, okay? Now, we talked about these being pies here, or you might have xylophones or whatever. This right here is a platter of apples and bananas, okay? So we will count that. Maybe you can just say, hey, it's a platter. And if you went ahead and just used the letter P for platter instead of A and B, then maybe you can see that this trial and error. There's nothing, you don't distribute the 2, you don't do anything with the 7, you just factor this as you would normally factor it. 1 times 15, 3 times 5, put the 3 here, the 5 here, a plus and a minus. You have a 1 times 2, you put the 2p in the p, and then you check to see if you get it right or wrong. So I'm just doing trial and error. All right, so trial and error, what's this get me? -10, +3. It gives me the -7 I need, correct? Now, Kevin, all you have to do now is, instead of writing platter, you write down apples and bananas. +3. And then you got apples plus bananas -5. And we would like you to clean it up a little bit by distributing the 2. So you can see the final answer to be like this. This one, there's not much of a change in the answer. So this would be the answer for number 11 when you get done. Now, in some answers, they get changed. See how it worked? Feel good about that? Yes, no? So I removed the A and the B and created them as P's, and I substituted it. That's what's called substitution. So that way the A and the B doesn't get in my way. Yeah, my shirt is inside out. This is inside out day, obviously. All right, looking at number 12. Now, remember, there are 3 different tables, right? I'm looking at those 3 sets. Are those the same? Diane says, no, there's something wrong with the one that's in the middle. You're like, no. The one in the middle is really kind of like -x + 2. How can I get those to look the same? Yeah, I can fix that. I can pull a negative out of this right here. If I throw a negative out of that, that will rewrite that as an x - 2. So I could rewrite this as 5x - 2 to the 3rd power minus 4 times x - 2 squared minus x - 2. Okay. Now the x - 2s could be whatever you want. It could be it's just an object. So if you need substitution here, you just give yourself a letter. You can write a different letter for that. So if you want to write that as 5p cubed minus 4p squared minus p, what do you notice about all of those tables or those terms? There is a p in every single one of them. So you got to remove that p. And when I get done with removing the p, I get 5p squared minus 4p minus 1. There's a placeholder there. Now, inside of parentheses, is it trial and error or not? Yeah, because I have an even number on the left side and a half that in the middle. So this fits the pattern. So now I'm going to do this. I'm going to do 2 sets of parentheses. I'm going to put a 1 here and a 1 here. I'm going to put a plus and a minus, and I need, in this case, a -5. So I'm going to put the 5p here, so I get the -5, and I'll put the p here to get the +1, so I get the -4p. Now, my p's in this case are not p's. They're really x - 2s. So I'm going to change all of these to x - 2s. So I'm going to rewrite this as an x - 2 parentheses Then 5 times x minus 2 plus 1, close my parentheses, open. Then I have an x minus 2 minus 1. As I said with these problems, anytime you have a parentheses, there will always be some sort of reducing on it. We have to combine all our like terms. Well, this one is really x minus 3, guys. This one is 5x minus 10 minus 1. Oh, sorry, plus 1. So I get this to be 5x minus 9. And I have an x minus 2. And that is the final answer for number 12. That's pretty complicated. I don't know how you guys are going to get that one on the test, but good luck. If you can handle problems like number 12 and you're really good with that stuff, then you should be fairly confident about what's going to be on the test, okay? If you're having and you're struggling with that, if I was doing this problem and I was struggling with it, I might just go like 5p cubed plus 4p minus p and then factor it from there, and hopefully I can get something out of it. Even though that this has a -1 in it, you could have still factored it. After we learn this, we do quadratics. All right, now, tomorrow we do psst. We do psst. You're going to be really good at psst tomorrow. Why? I entertain you. It's good enough.
I was hoping you'd say no. I was hoping you'd say yes.
No, I would definitely.
You know there's like those teacher communities?
Yeah, I do. It's not me. All right. Yeah, they're all over the place.
You know who?
No. Fire?
Lee.
Leanne Rhymes?
Leanne Morgan.
No.
No, Leanne Morgan. She's not YouTube.
No. Didn't have her. All right, now.
She's a comedian.
Okay. Is it somebody who cleans toilets or something? Yeah. A commodian, you said?
You know who?
You remember this worksheet from yesterday? Find it. Number 10. It's the back side. The worksheet that we started yesterday. So I'm going to stop the recording. Bye, fam.